Hello everybody, Root Beer here, and if you're watching this video, it means that like me, you're ready to start another sequence of contest question videos. I thought we'd start covering the 2013 Canadian Senior paper. So once again, that's the paper for grades 11 and 12s. Younger grades are certainly welcome to try, but it's aimed at an 11th and 12th grade North American education. Okay? As I usually try and warn you, although sometimes I'm not so good at it, before you watch these videos, please click on the link below and get a copy of the contest for yourself from the CEMC website. They're the guys who make it and put out this contest and distribute it and market and the whole thing. Try the contest for yourself. It's a 2-hour, I think it's 2 hour, just let me check. Yeah, 2-hour time limit. So, try it under contest conditions, see what worked, see what didn't work for you, then come watch these videos, then read the online solutions, and you will gain so much more than if you just watch this, because I'm going to be doing things and you're like, oh, why is he doing that? Because if you don't have a sense of what the question's asking, I might be going a little too fast for you. So please, guys, try the contest questions ahead of time before you watch these videos. Now, assuming you've paused the video and done that, and I'll give you another second to pause. So assuming you've done that, let's start looking at these questions together. So we'll dive right into it. Question 1 in Part A. Remember, Part A, full marks will be given for the correct answer. Part marks will be awarded only if you don't have the right answer and you have good justification or relevant work written down. Okay? So question number 1. In the diagram, so this diagram over here, that's what they're referring to. ABCD is a parallelogram with A, B, C, D in the first quadrant. Okay. What are the coordinates of C? So we're given the coordinates of A, B, and D. We're asked to figure out the coordinates of C. Okay. So A is at 2, 3. D is at 3, 7. And B is at 7, 3. So as parallelograms go, they're going to the opposite lengths. So AD is going to be the same as BC. So if we can figure out how we get from A to D, so how does our x coordinate change, how does our y coordinate change, we can apply the exact same changes to B to figure out the coordinates of C. So maybe to get from A to D, we go to the left by 5, or so we go to the right by 5, and we go up by 6. To get from B to C, we would go to the right by 5 and go up by 6. So let's figure out that relationship. We'll draw ourselves a little copy of the picture. It won't be perfect. It never is. That's okay. Important thing is that we try. So A is down here, and he's at 2, 3. We go up some distance up and over, and we get to D, who is at 3, 7. And over here we have B, and I've quite forgotten the coordinates of B, so we'll get those in just a second. We want to finish our little parallelogram. We got C. So what were the coordinates of B? Let's check. B is at 7, 3. Okay, sort of opposite of D. All right. So B is at 7, 3. So we're just writing down what I've already stated. The same way we get from A to D in terms of changing our XY coordinates is the same way we get from B to C. So the x coordinate of D minus the x coordinate of A 3 minus 2 equals 1. The y-coordinate of D minus the y-coordinate of A, that's going to be 7 minus 3. So we're going to be at, what is it? 4. Had a little lapse in concentration there. So Cx minus Bx is also going to be 1. And Cy minus By is also going to be 4. Okay? And this would work no matter where they were located. I mean, you might notice that A and B are at the same height. That's irrelevant to the question. It really is. Okay, that might trip you up and think that this only works because we have a flat line here. It really doesn't. This relationship would hold no matter what A, B, C, D would look like. So Cx minus, well, what's the x-coordinate of B? That's 7. So Cx is equal to 8. Cy minus By, well, what's y? By, well, that's 3. That's got to equal to 4. So Cy is equal to 7. That makes sense that it's 7. I already mentioned that AB is sort of flat. It's parallel to the x-axis. So being a parallelogram, we would expect DC to be the exact same direction. It is also flat. It is also parallel to the x-axis. So we're looking good. Okay. So now we just need sort of a therefore statement. If we were doing this question on the contest, we wouldn't necessarily need a therefore statement. We can just write down the coordinates in the little box provided. So what we just figured out was 8, 7. Okay. Nice, clean, simple introductory question. We write down the 8, 7 as the coordinates, and we move on to question number 2. And that's what we're going to do right now. We're going to move on. So I'll see you guys in the next video for question number 2.